Hey everybody, thanks for checking into another math video here. This one is going to be about rational exponents. What the heck are rational exponents, you may be thinking? Sounds kind of scary. Well, rational exponents are just exponents that happen to be fractions, okay? That's all they are. Something like 3 to the 1/2 or 2 to the 4/5, okay? Sorry, so that's what rational exponents are. Does that ease your mind? Probably not. A lot of people think fractions are kind of scary and exponents are kind of scary. So when you make exponents into fractions, what the heck is going on there? All right. Well, let me explain simply, I hope simply, to explain it this way. Rational exponents, or sometimes we call them fractional exponents, are just another way to write the root of a number. Okay. For example, square roots or third roots or something like that. So instead of using a radical to write a root, we can use an exponent to write that same root. And sometimes using exponents is a more convenient way to write that expression. All right, and I'll show you an example later on about why it might be more convenient sometimes. But first, let's look at some examples to kind of get our hands around this. Okay, and I thought maybe an easy way to do this would be to use radical form on one side and the exponential form of the same number on the right side. Okay, so for example, the square root of 2, another way to write that is 2 to the 1/2 power. Okay, so radical, that's with the little radical symbol over the 2, we call that a radical, and then the rational exponent of 1/2 means the same thing. Okay, or the square root of 3x. You could write that with parentheses around the 3x and then raise that to the power of 1/2. They mean the same thing. Okay, not saying one's better, one's right or wrong. Just they mean the same thing. So what do you think 75 to the 1/2 power would be? Yeah, that's the square root of 75. So actually, anytime, folks, anytime you see an exponent of 1/2, it just means square root of the number. Okay, so square root means an exponent of 1/2. What about other roots, like the third root of 8, or the cube root, sometimes we call it, the cube root of x? Well, the cube root of 8 is 8 to the 1/3, and the cube root of x is x to the 1/3. So anytime you see an exponent of 1/3, it means cube root of a number. All right? So you may be asking, maybe where does the 1 come from in those fractions? Okay? I mean, it makes sense a little bit to say cube root and then the fraction has a 3 in it, or square root and the fraction has a 2 in it, but where does the 1 come from? Well, it comes actually from the power of the number underneath the radical. We never write that 1, but it's there. So that's x to the first power, and there's the cube root of x to the first. Cube root of 8 is the cube root of 8 to the first power, or the square root of 75 to the 1 power. We don't usually write that 1, but that's where it comes from in the fraction, okay? So let's explore this a little bit more with some other examples of this same kind of thing. Let's see, what if we had a number like the square root of 3 to the 5th power? Okay, so now the 3 has a power and it's the square root of that number. Well, what that equals is 3 to the 5/2. So you take that power and put it on the top of the fraction, and then the root is on the bottom. Now, square root, we don't usually write that 2, but that's where it comes from, okay? So it's the root of the number. Let's see, so then the 4th root of 7 to the 3rd power, you could write that as 7 to the 3/4 power, all right? So here's a couple more examples, and let's just go to the in general case here. In general, you'll see this if you look up this topic on, I don't know, on some other YouTube channel or Wikipedia, or some other, maybe in the math book, it has this exact little thing here. The nth root of a to the m power is equal to a to the m over n, the power over the root. Okay, so that's what I want you to come away with here at this point, and that is this, that rational exponents are always written in the form power over root. Okay, and one of the things that one of my high school teachers showed me a long time ago to help me remember this power over root idea was he just kind of drew lightning bolts over power and drew kind of root-like little lines going down below the word root. So power is from above, root is going down into the ground, so it's power over root. And if that helps, great. All right. All right, so what I want to do next is talk a little bit about calculators, because calculators are a challenge in this topic here. If you want to evaluate one of those numbers, like what the heck does it actually equal, all right, you're going to be using one of these two keys on your calculator. And the problem is that not all calculators have these same two keys. Sometimes it's the x root of y, or it's y to the x power. They don't always look the same, and sometimes a calculator might have both of these keys, or it might just have one of them, and then you have to use the second or the shift key to get the other one, and it's confusing. Every calculator is kind of set up a little bit differently, so your job really is to look at your calculator, whether it's the one on your smartphone or whether it's a separate actual math calculator. It's the same kind of problem. You have to know how to use it to get these values. So what I was going to do here is just give you a couple of values to check. All right, if you can get your calculator to do this, then you're using the right sequence of keys to press. For example, the cube root of 8, or I'm sorry, the cube root of 2, or 2 to the 1/3 power, either way, that is equal to approximately 1.259921 dot dot dot. It goes on forever because it's an irrational number, all right? Or here's one that's not irrational. The 6th root of 64 equals exactly 2. So there's a couple of examples that you can check, and if you get your calculator to give you these results, all right, then you're using the right sequence of keys to press, all right? By the way, there's the alternate form of each one of those numbers, the cube root of 2, or 64 to the 1/6 power. Okay, so now I mentioned that sometimes using rational exponents is a more convenient way to express something. Why would it be more convenient? Well, here's one possible example. Let's say you've got a rectangle, and one side of that rectangle is the cube root of 2x, and the other side of that rectangle is the square root of 2x. And your job is to figure out a way to write the area of that rectangle. So you're going to multiply base times height, the cube root of 2x times the square root of 2x. But how do you do that with radicals? Well, actually, it's kind of challenging to use radicals for a little simple problem like this. But if you rewrite them first using rational exponents, now we can use laws of exponents to help us simplify this expression, all right? So you've got 2x to the 1/3 times 2x to the 1/2, and hopefully you remember that when you have two numbers, if the base of two numbers is the same, but the exponents are different, and you're multiplying those together, you can do that by just adding up the exponents, okay? So 2x to the 1/3 times 2x to the 1/2 is the same thing as 2x, and then the exponent would be 1/3 plus 1/2. Okay, well, darn it, now we have to add fractions together, but okay, it's not so bad. 1/3 plus 1/2 is the same as 2/6 plus 3/6, and that equals 5/6. Okay. So that means then our final expression there for the area of that rectangle is 2x to the 5/6 power. Now that may be kind of an odd or kind of mysterious looking expression. Don't worry about that too much, what that means. Our goal here at first is just to kind of get our hands wrapped around the mechanics of the way you write these things, okay? We're just learning different ways to kind of expand your vocabulary of numbers, all right? So we're going to finish up here with just a whole bunch of examples showing up on this screen, and feel free to stop the video at any point, or maybe after they're all done. You can see them all out there. Copy a few of them down. Think about them, for example, a little bit, and see if they all are consistent with your understanding so far about this topic of rational exponents. Each one of those has been double checked, and they're all correct. So you can look at those and hopefully use them as you do your practice of using rational exponents, okay? Hopefully this will just kind of get you started on using that. Alrighty, well, once again, thank you very, very much for watching this video all the way to the end. I hope these examples are helpful to you. I hope you understand a little bit more about rational exponents, that they're not so scary, and there's just a different way to write a number that you're already sort of familiar with. Alrighty? Okay, once again, thank you. Hope to see you soon. Be well, everybody. Stay cool, stay smart, and as always, do some good math. Bye-bye.